to talk about the chemical kinetics. Chemical kinetics. Now remember, we know the different type of chemical reaction, and what does the chemical kinetic means? Actually, the rate at which change of chemical reaction occurs is called chemical kinetics. It can be resembled with the speed. Like for example, remember, consider you are moving from point A to your point B. Now the distance between them is your, like for example, 160 km, and the time taken to cover the distance is your 4 hours. Now the speed is equal to distance by time, like for example 160 by 4. In the same way, we can talk that chemical kinetics is equal to, we will take change of concentration divided by change of time. In the most of the cases, we take the concentration as mole per liter, and time as second. Thus the unit of chemical kinetics will be mole per liter per second in case of reaction in solution. And if we take gaseous reaction, for that cases we will take pressure per unit second. Like for example, we will take atm per second. This is the change of pressure. Now see how the mathematical equation looks like. Mathematical equation. We will see the mathematical equation. Like for example, a reaction begins where A is your reactant and P is your product. When the reaction begins, like for example T is equal to 0, the concentration of A is maximum. We take that as A initial. We take the concentration of A as A initial, and at that time product is 0. And after certain time, we take A as A final, and at that time product is your P final. Now remember, as we have started the reaction with A initial, and after some time it goes to A final, that means the concentration of A final is less than the concentration of A initial. And as you can see, in case of product, we know that PF is greater than P initial. In here the P initial is 0. That means with respect to time the concentration of reactant increases, and with respect to time the concentration of reactant decreases, and with respect to time the concentration of product increases. Now see, rate with respect to rate of reaction with respect to your reactant. In this case, we will take at numerator change of concentration, as we know, and change of time. The change of time will be dealt as change of time is equal to your delta T. Now see, here the change of concentration means A final minus A initial, and here is your delta T. Now remember, as A final is less than A initial, we will get the result as negative delta A. That means delta T. Now see, you remember here the negative sign means rate. Always remember, negative sign means rate with respect to reactant. And in case of product, whenever we determine the rate with respect to the product, rate with respect to product, in this case we know that in numerator will get change of concentration of product divided by time taken. That is, it will be your, as we know, in initially the product of concentration of product was 0, so we will get a positive sign before that. Remember, for product the rate is given as positive sign, and for reactant it will be your negative sign. It denotes product. Now see, if we plot a graph with respect to concentration versus time of reactant and product, we will get, if I draw the graph, this is the concentration, and as we know, initially A was A initial, and with respect to time that concentration of reactant decreases. Here is the time, and for the product, initially the concentration of product was 0, and with respect to time that increases. That means this is your product and this is your reactant. Now see, the rate of the reaction can be expressed in two terms, that is instantaneous rate of reaction and average rate of reaction. If I write rate of reaction, there is two methods for expressing the rate. One is your average rate of reaction, and another is your instantaneous rate of reaction. Now remember, the average rate of reaction is that whatever I have told you earlier, like for example for reactant it will be your minus delta A divided by delta T, and for product it will be your plus delta P by delta T. Remember, for the average rate of reaction we express the concentration by your delta term, that denotes the change, but in case of instantaneous reaction we take very small interval, very small time interval. As we know from the limit, that is limit delta T tends to 0, delta A divided by delta T, and this is your derivative, it denotes your derivative. That means we will write in this case dA by dt with the negative sign, and for product limit delta T tends to 0, delta P divided by delta T. We will denote as dP by dt. That's it for today. We will continue this chapter in next classes.